Okay, let's dive into this. So we've talked about AIs that learn with a teacher and AIs that learn by just studying a bunch of data. But what if I told you there's another way, a really fascinating way for an AI to learn that doesn't need any of that, a way that's all about learning from its own mistakes?
I want you to think about something for a second. How does a baby learn to walk, right? Nobody gives them a user manual. There's no instruction book. They just try. They wobble, they fall down, they get back up, and then they try something just a little bit different, over and over and over again.
That's it right there. It's all about trial and error. It's the exact same way you learn to ride a bike or how you finally beat that super hard level in a video game. You just experiment, you see what works, you learn from what doesn't, and this very idea, this simple principle, is the heart of a super powerful field in AI called reinforcement learning. To really get it, just think about the classic carrot and stick. Imagine you're trying to train a puppy. When it does something good, like sitting when you ask, you give it a treat. That's the reward, that's the carrot. But when it does something you don't want, like jumping on the sofa, it gets a firm no. That's the penalty, or the stick. It learns pretty quick which actions get it the good stuff. Well, reinforcement learning is basically just that simple idea, but turned into math for a computer. We create an AI, which we call an agent, and we drop it into some kind of world or an environment. And here's the key. We don't tell it how to do anything. We just tell it what the goal is by giving it points, a reward, when it does something right. Its entire mission is to figure out for itself how to get the highest score possible.
So this whole process, it really just breaks down into 4 key parts. It's kind of like a recipe. First, you've got the agent. That's our AI, the one doing the learning. Second, the environment. That's the world it lives in, maybe a game board or a factory floor. Third, you've got the action. Those are all the possible moves our agent can make. And finally, the most important part, the reward. That's the feedback, the points, the carrot it gets for making a good move.
And this is where it gets really mind-blowing. This simple loop of just trying something and getting a reward can scale up to create incredible, sometimes even superhuman levels of skill. Let's look at a few amazing real-world examples to see what I mean. The most famous example, you've probably heard of it, is in game playing. I'm talking about Google DeepMind's AlphaGo. This was an AI designed to master Go, an ancient board game that's way more complex than chess.
So let's break it down using our 4 parts. The agent, that was the AlphaGo software. The environment, a virtual Go board. Its action, super simple, just placing a stone on the board. And the reward was as simple as it gets. It got a +1 for winning a game and a -1 for losing. That's it. By playing millions and millions of games against itself, it learned from every single mistake until it started discovering strategies that no human had ever even dreamed of. It literally became the best Go player in the history of the world.
It's not just about games. Not at all. Reinforcement learning is totally changing the game in physical robotics. Just imagine a factory, maybe somewhere like in Sialkot, and there's a robot arm that needs to pack boxes. Okay, so here, the robot arm itself is the agent. Its environment is the workspace, the table, the box. The action is picking something up and putting it down. It gets a positive reward when it places an item correctly, and a negative one if it messes up and drops it. After thousands of tries, it teaches itself the perfect grip, the perfect angle, the perfect speed, all without a human having to program every single tiny movement. Let's do one more, a really cool one. Managing a complex system in real time. Think about a crazy busy intersection, something like Kalma Chowk in Lahore during rush hour. Now imagine an AI is in charge of the traffic lights. In this scenario, the AI control system is our agent. The whole traffic intersection is its environment. Its action, just changing the lights. And the reward system is just brilliant. It gets positive points when traffic is flowing smoothly, and it gets negative points whenever a traffic jam starts to build up. It learns to adjust the timing perfectly based on what's actually happening on the road, not just some fixed schedule. So what do all these examples tell us? Well, it's pretty clear. Reinforcement learning is the future. It's the key to making truly autonomous systems, from self-driving cars to the next generation of smart robotics. This is the tech that lets machines adapt and learn in our messy, unpredictable world. So the real question is, are you ready to be one of the people who builds that future? Because, you can be. If any of this sparked your curiosity and made you think, hey, I want to do that, then you should check this out. The Skill Development Center at the University of the Punjab is offering a short course on AI.
It's right there on the Quite Awesome campus with on-campus classes that are all about getting hands-on practice. So you can stop just hearing about it and actually start building the kinds of intelligent agents we've been talking about. It's really the perfect next step.
So I'm going to leave you with one final thought. Now that you get the basic idea, teaching an AI through trial and error with rewards and penalties, what's a big, complex problem that you would want to solve with this? What would you teach an AI to do? Because honestly, the possibilities are absolutely endless.